Alright guys, hopefully this worked. So if you understand coordinates, I could ask you about this parallelogram, you'd understand that this side length here is A, and of course the opposite side is also A. So this distance across here is A. And if you understand coordinates, you understand that this vertical distance here is C. So we've got our y coordinate up here for this coordinate, for this vertex would be C. We just got to come up with the x. This distance here, I think it hopefully is obvious, that's B. So this entire distance across here to get me to that vertex would be B plus this distance A. And you could think of it on the bottom too. This is A. This little triangle here, if you were to cut this little triangle out, would fit down here if you just flipped it around, rotated it around. So this distance is A plus B, this little distance here, and then I go straight up C units tall. So hopefully it makes sense that that last coordinate would be A plus B, comma C. In other words, this horizontal distance is A plus this little bit here would be B, which is symmetric with that or congruent to that little segment there, and the vertical distance is C. Alright, this next one has got two parts to it. We're going to draw this triangle, and hopefully you can look at that and go, oh, that appears to be isosceles. I want to put an isosceles triangle and move it up from the origin a little bit because I'm going to use that coordinate. You can use that corner for the second triangle we're going to work with here. This is a little bit of a tricky one. I'm going to give you this point, which is 0, comma B, because it has no x coordinate, and it's going up B units. That's just like your y-intercept. And I'll give you the top one, 0, comma C. See if you can come up with this one. And don't overthink this. You can't get both values. You can't get x and y, but you can get one of the two coordinates. So think about whether you can get the x coordinate or the y coordinate. Hopefully you realize there's no way to get the x coordinate. There's no ratio involved here. This distance is just A, some other distance on here. But the distance for the y coordinate here is how far up this is. If you just work across here and think of where this point is, horizontally across from here, this is exactly between B and C. We spent a lot of time figuring out how to find a point that's between two other points. Hopefully you realize that this point, this y coordinate here, is exactly between B and C. It's like the midpoint of B and C. And you guys, of course, remember how to find a midpoint. A midpoint is adding the two numbers together and dividing them by 2. So this third vertex, is A units across. That has nothing to do with B and C. But its y coordinate is the average of these two y coordinates here, which is why I have B plus C divided by 2. So there's an application of the midpoint formula. Second one I want you to mess with, throw this triangle over here in quadrant number 2. And I'm putting this corner at the origin to make it easy. And you might have looked at it today. It looks like it might be a special triangle. It's a 30, 60, 90. And I'm going to do this in terms of D. Just by giving you this distance here, negative D, comma 0, or that location, you should be able to get this one in terms of D, if you know your special triangle ratios. So it's kind of an opportunity to apply that 1 to rad 3 to 2 ratio. And it is a little messy because I gave you the side that's across from the 60-degree angle. If you just look at the scale of it, there's the 90, there's the 30, there's the 60. So this is your 1 to 2 ratio. Unfortunately, this is the rad 6 or the rad 3 side of it. So to work backwards from this, you'd have to divide by rad 3 to get that side. And then whatever you get for that, you'd have to double it. So this really is going to be, this coordinates for this one are really going to be negative D, comma something. And the something is this vertical distance. Well, that's negative D divided by rad 3. So I'm going to throw a little fraction in there. It doesn't seem to be showing up there. There's a little fraction bar here. Doesn't show up on the screen too well. But to really find that, you'd have to do negative D divided by rad 3. And yeah, I can see it's not showing up very well. This is D over rad 3. You can't leave a radical in the denominator. So most of you know that'd be D rad 3 over 3 if you multiply top and bottom by the radical. Hopefully that showed up there. So it's a little bit messy to see that. But hopefully you understand the components of it. Negative D is the distance to the left. That's where this comes from. And the vertical distance is really the y coordinate here is D rad 3 divided by 3 because it's, this is shorter than that long leg. And that's all you got to find. Just that one missing one in terms of D using special triangle ratios. All right, give you a second to draw a trapezoid. And there's two words here, not just a boring trapezoid, I think you probably know what adjective is going to go here. It's going to be an isosceles trapezoid, just to make it a little easier to label points on here. And I'll give you a couple of these. Again, I'm going to start at the bottom right with a comma 0. There's this bottom base, this bottom distance is a. And I'll give you the top right. That's a plus b comma c. You should be able to label that last one, and I'll come back in part 3 and reveal that in a moment. But you should be able to get this in terms of a, b, and c without too much thinking. It's a lot like a parallelogram, just some things flipped around. Okay, good luck.